Well, it's not easy for the technicians to manage with the change of computers all the time, and I hope that they will keep you awake with this last lecture today. Actually, the biomechanics was what I studied in the 80s, in the last century. So it's almost 40 years ago when I started to do this research. And here I said, clinical biomechanics, what does it mean for spine surgeons? But I also add to the hip surgeons. But I'm very pleased to see so many hip surgeons interested in the sacroiliac joint. It isn't the case in Sweden, however, but maybe there will be in the future. I see patients every week, at least 4 patients with sacroiliac joint pain. Some are referred from colleagues, some have been fighting to come and see me, and in different ways, because it's not so easy in Sweden to see a doctor who treats sacroiliac joint. I say to my colleagues, open your eyes. Because if you open your eyes, you will see something in the forest. You will see the trees, and that is the most important thing. And we heard that also in another talk. It was Thomas. I said, when he started to talk about the sacroiliac joint, then a lot of patients was coming in. And I think it's better that the patient will come in and be assessed to see if they have something that you can treat in one way or another. So again, I come here with the basics. Look at the patient, listen to the patient, examine with the proper test protocols. We have discussed that before today, and I will not talk too much about that now. I will talk about the white spot on the map. And it was how it was when I entered the department in Malmö, 1985. Some were not born at that day, I think. And I had the opportunity to work to the professor, late Professor Bo Nilsson. He allowed me to study this problem of sacroiliac joint. He said, well, I will give you some good advisor, but maybe there will not be a PhD. And what was written before? Not so much. Solonen, a Finnish anatomist, he stated that sacrum is like the keystone of the bridge. Here, this is the keystone here, the bridge. This might give the impression that the sacrum with its form closes all the movements in the sacroiliac joint. What actually happens is that the irregular surfaces in the sacroiliac joint and the strong ligaments can stand the loading of the joint. It works so with normal people. Another thing what I found, it was Capangi, a French anatomist and orthopedic surgeon. He had this drawing in the textbook. It was a fantastic drawing. And you see how big these arrows are everywhere. And it tells about movement in the sacroiliac joint. And the impression given is that movements are considerable. And he also proposed the movement in the sacroiliac joint about the notation and the counter notation. I will show his proposals of movement were correct, but with less magnitude. And in the debate in the ortho scientific group those days, it was pain from the sacroiliac joint doesn't exist because it doesn't move. So the main issue for me was to show movement in the sacroiliac joint. And actually, like Galileo, I could prove that there was a movement. You know, the Earth is rotating around the sun, and there's a movement in the sacroiliac joint. The fantastic thing was in the closest university in Lund, there was an anatomist and an engineer. He invented the radiostereometric analysis. With the radiostereometric analysis, you can do such fantastic studies to measure movements to the amount of 0.2 to to 0.3 millimeters. He did a study, actually, on 4 patients. And they have movements, but actually they couldn't see any structure in the movements, but they didn't do any provocation. And those years I was fully aware, we can do the perfect provocation, and we will show the big movements that exist in the sacroiliac joint. It was what I was thinking from the beginning. They could prove the center of rotation. Here, the center of rotation behind the sacroiliac joint, and they could show there's a sliding movement along the joint. That was what they could prove. I have to tell something about the radiostereometric analysis, because it was the basic of my research. The principles is that you need one fixed segment, so that in our studies we decided sacrum to be the fixed segment, and it was rotations around the sacrum or the bow ilium. And then you need a Röntgen room, so we built a Röntgen room with double X-rays here, and that is like basic for making it possible. And then I implanted tantalum balls inside the bone, so at least 5 tantalum balls in each pelvis and in the sacrum. And with that inside, you could measure those movements with high accuracy. And this is a setup. Two X-ray tubes. You have the patient here with the tantalum balls, and then you have a plastic plate here with also tantalum balls that on the perfect location, and then you have the films. And then from that you can. That was the thing with Selvik. He made this mathematic protocol where you can analyze the movement. Now I will tell you what I found. The result was not what I expected. I expected hypermobility. But what we found, it was a normal distribution. So there were some outliers. Outliers was almost 3 degrees. And those who had almost no movement at all. I mean, it's 0.2, it was like no movement. But most of the patients were in the middle, about 1.5 degrees of movement between those positions, supine and standing. So here it is. Between supine and standing, it was 1.1 degree, and 90% of the movement was around the x-axis. Then we compare supine to sitting, and there, what we found, we saw this inflare. I mean, those arrows here, but it was only 0.5 degree. It was only 0.5 degree, but it was really constant on both sides. It was 0.5 degree. So when you force the sacrum forward, there will be inflare in the ilia. In standing to prone with hyperextension, then we could show the counter notation, and that was the biggest movement. We could find the movement up to 2 degrees on the provoked side and 1.5 degrees on the non-provoked side. So you could have an asymmetric movement in the joints. But our results were challenged. There was some Americans, they proved 20 degrees of movement in the sacroiliac joint with some skin measurements, and they said that we had the wrong provocations. So we did a study with extreme provocations, and it was alternating straddle. So we put one leg in front and the other leg in front, and they measured the movements. And well, we could see that there was a movement about 2 degrees from the one upper end to the other one. So it actually there was a good reciprocal movement, and from that we also say that most likely in walking there could be this type of reciprocal movement, but not that big. But still it says that there is a movement as a reciprocal movement in the walking. I will come back to that a little later. This was what I said. This is the biomechanics. It's a form of force closure. There is a movement, but it's normally distributed. Then I had a favor to meet Andrew Fleming, a very famous anatomist and physiotherapist from Holland. And they produced this theory of form and force closure, also to understand how it works. So this is the form. If you have a form that is rectangular, then you have no movements. Then it's fixed like bricks. And then here, if it's only the force and no form, then you need very strong force to keep the bricks together. But the reality is something in between. That's why it's called the form and force closure. Because we did another study. We did this in German, it's called Rücklauf. And it in English literally is stork test. If you stand on one leg and lift the other up like that, because it was decided to be a very important movement analysis proposed by Kirkcaldy-Willits. Here you can really diagnose the sacroiliac problems. You can see the movements. So that was very interesting to do this study. What we didn't understand when designing this study was biomechanically standing on one leg double the force of the sacroiliac joint. And that's also interesting to understand what happens when you walk. Then you double the load of the sacroiliac joint. So that means that I double the arrows here, because you take the load from the spine to one leg. And that increases the friction in the sacroiliac joint. That is a force closure. And this is also what we found. The movement were reduced. So it was not increased movement. So actually, I wrote in that paper to spine that is an illusion. It is an illusion that there is a movement in the sacroiliac joint. It is actually that the pelvis is rotating around the hip, and you think there is an increased movement in the sacroiliac joint. So that was the only way of understanding this. So this was like that. And the case is what we have to realize from the clinical way. If you increase the compression of the pelvis, like with the belt we saw before, then you can have a reduced movement in the sacroiliac joints. So it's, I say, pelvis will give, belt will give this, how to say, function, but also with the physiotherapy to work with the anterior and the posterior slings. And then I come to the external fixation, as I showed you before, and that was what I used to really be allowed to do surgery on those years, because when it was really not allowed to do surgery on the sacroiliac joint. But after we started with external fixator, I could do it. And we had 10 patients, and it was the same procedure with everything. We measured the movement before and after, and what we could see, that if you put the external fixator here in the anterior part of the iliac wing and put a small force, not the big force, a small force, and then you have a big counterforce on the back side here, it is a ligament, then the total force of the sacroiliac joint was addition between this small force and the big force. Then you have a good compression of the sacroiliac joint, and that's the way how you could reduce the movement with the external fixator. And you see the woman, it's my English patient. She came to Sweden to do surgery, and she was almost going to take her life because of so bad pain. And she's fantastic lucky. The last time I had a message from her, he was in Mount Everest climbing. So it was a good outcome from that surgery. I have shown this picture before, but I think it can be repeated, because this is the thing. It's a load from the spine to the hips, and we have to realize that. So it is a hip, spine, sacroiliac problem. As well, I showed this that I think it's important to talk about joint stability. It is what we need. We need joint stability, we shall treat those who don't have the joint stability. and not those with pain, because I think it's about stability in the joint. But still, I allow them to have pain. Do you want to see this movie again? Or shall I stop it? You see this? Yes, you don't fall to sleep, because it is very interesting to see how she can walk so good with the external fixator. People think, oh, it's so much pain with this external fixator, so you can't hardly move. But it's so much better. And I think in this movie I have something more than just walking. I will see. I have some more, maybe, if I'm happy here. Yeah, there will be more tests, because it's very interesting to see the ability to load. And if we're happy, she will walk on some stairs here. Yeah, here she is standing on one leg, and look how easy she stands on the right side. But on the left side, she really struggles to find the balance. She goes over to the left and the right side just to find the possibility to stabilize, because she has no muscles in the buttocks to stabilize. And I will also ask her to walk on the steps, on the stairs. You see, on the right side, no problem. On the left side, she really struggles. So stability in the sacroiliac joints, it decreases the function so much. And then what about the lumbar spine? This is a movie that I received from Professor Lewick. And he has been working very much with sagittal balance. And actually, I taught him to do sacroiliac fusions as well, and he's very happy with that. And from his perspective, you see here that it rotates all the time. But if you have a flat spine, you have a counter notation in the sacroiliac joint. And I do it like that instead. And if you have a counter notation, then you move the force more posterior, and you come to an unstable situation, because if you move anterior, it's the same thing that happens when you put the frame on. You have much more stable situation. So those patients that we had operated in Sweden, at least, for spine fusions, they were put in the flexed position, and then we took away the normal sagittal balance. I have one case here, and she came after this lumbar fusion, and she had a lot of pain in the sacroiliac joint. So it's when she was standing like that, it's also okay. But when you stand straight up, then she had pain. So I fused her, and you can see here how the sagittal balance changed from more anterior than here. Then she can balance, because then she stand up without pain. Because in the previous first year, she had pain all the time, but now she can stand up and there's no pain. I think it is like a salvage procedure for this patient group. I don't know if you have them in other countries, but we have them in Sweden. And again, I think biomechanics is the fundament of the diagnostic procedure. You have to understand how it works, and the compression of joints gives the stability. I think that's very interesting. And again, some how to say, thanks from my patients.
I guess I have a little bit of a philosophical question for you about compression, because you've mentioned compression quite a bit with the force closure and the realities to get compression. The way that a lot of us fuse the SI joints don't involve compression at all, but those patients do great. So why is there a difference of just fixing them versus compressing them?
Well, the compression we used with the external fixator, it was not much.
Okay.
If you remember that picture, it was a very small force that we compressed with. And if you have the patient in the prone position when you do the surgery, you will have the same anterior rotation of the sacrum. Yes, but if you try to fuse them in the supine position, you will have the opposite, and then you have not the how to say the biological how to say compression of a joint. So for you don't need to have the compression to do the surgery. No way.
Okay.
No.
Okay.
You show that there's not that movement at all. And I also done this analysis and I found the same thing.
Yes.
What do you tell the people that say that they can actually feel the movement?
Yeah.
Is it the SI joint movement they feel, or do they feel the whole pelvis moving? Because of a spasm, you can actually get this feeling of asymmetry, but is this the whole pelvis that actually has moved, or is this the joint?
Yes.
Have you any idea, or what do you tell the people?
Without discussion, we saw previously today some pictures of forward bending, and forward bending is in German it's called Vorlauf, and that gives the impression that there's a lot of movement on one or the other side. And the same was with this standing hip flexion test. But I will say what the examiner thinks, it is an illusion. It is rotation of the entire pelvis on over the hip. And I can tell you, because I was really searching for the patient with the rotation inside inside the pelvis. And I have 40 patients with tension boards. So I had those first 25, then another 15. And once I had a patient coming in with a lot of pain, and she had already tantalum boards, so it was one of my patients. And she was totally twisted, extremely twisted. And okay, I was like, now I can see the movements in the twist. And I did this RSR, and there was no difference. So actually, she looked very twisted, but it was the force of this lumbar spine. So she has an acute lumbar spasm that rotated. It looks like she had a rotation in the sacroiliac joint, but it was a rotation in the hip in the same way. So I think it's important. We shall not make too much importance about analyzing the movements with our fingers. I think that's very, very important. We shall not make too much, effort to say, oh, I can analyze this and analyze this. We actually also did the reliability study. Four persons, one chiro, one doctor, and 2 physios. And we tried all these tests that we had discussed. And about the pain provocation test, I think it was better to flip a coin than to see something. And actually, the interesting thing, it was the chiropractor. He had more left-sided pain than all the others. And we were a little confused. Why? Then I saw how he was analyzing. He always put his head like that. And if you put the head like that, it looks like you have more movement on the one side. So, yes, it was quite funny. So from that study, we say there is no possibility to have a reliability in movements test. You can have reliability in pain, but not movements. Yeah, to us.
Now, I read all the literature about movement in the SI joint, and I agree with you.
Yeah.
And the measurements that are most precise show less movement than the with the less large precision, like skin markers or hands or anything.
But again, it moves. Yeah, but it's so small movement that we can't detect it with our fingers. Yes.
Yeah, I'd like to kind of go back to the pelvic parameters that Carlton was talking about, and you presented, and you show your motion and your model. And, you know, I criticized about over a decade ago by a leader in reconstructive spine surgery when I presented an SI fusion. And he got up, he was like, you ruined the chance for that patient to compensate for their, you know, their pelvic parameters. I went, but only, how can that be? And when you look at your models, all this compensation is either at the hip or the spine. And I'm agreeing that, yes, it can create problems when you're not, your alignment in your pelvis isn't right, but the stresses are causing the problem, not the motion, right?
Yeah. Okay, thank you.